Okay, lesson 6. So we are almost at the end of outcome R3. So 4.5, completing the square, looks specifically at the conversion of general form, which is this first one we have listed here, where we've got an x squared, an x, and a constant term, into vertex form. Because vertex form, we've seen, it's super convenient when it comes to graphing. So we want to be able to convert into vertex form to be able to be a little quicker. Now I'm going to change these steps a little bit. So I don't like actually moving it onto the left-hand side. Okay, what I recommend you do is that we add this value to the right-hand side, but that's going to be inside the brackets. And we're going to subtract it outside the brackets. It's just a personal preference, and then we're going to factor it. Okay, if you see what I'm doing and you're not super crazy about it, that's totally fine. Then you can by all means use this other method. And when it comes to our next lesson, sometimes that other method can be useful as well. Just to give you some names, the original method that's described here, it's that whole idea of whatever you do to one side of an equation, you do to the other. This strategy that I describe and that I'm going to walk you through actually is like, we call it adding 0, because we're adding something, but we're taking it out as well. So it ends up kind of evening out and our net change is 0. So example 1 is just strictly applying this principle. So the first thing that we do is we factor out the 3. So we're left with x squared minus 4x. And we're going to leave that 7 on the outside. So that's what I'm talking about when I'm talking about brackets. From here, we do the half b squared thing. So b is always your term attached to x. So I'm going to go negative 4 divided by 2 squared. And I'm going to plug that in here. And what we see is negative 4 divided by 2 is negative 2. Squared is positive 4. So I've added 4 here. Sorry. I'll keep my colors consistent. But actually, I've added 4 3 times. So I've added 12. So I'm going to take 12 away on the outside. So when I go to rewrite this, the whole point of this is to create that perfect square so that I get this effect happening in my equation. So the perfect square that's present here is x minus 2 squared. 7 minus 12 is negative 5. And so that is my equation in vertex form. You can pause the video here if you want to give this a shot on your own, or you can just follow along. So again, I want to factor out that coefficient of x squared. So in this case, it's going to leave me with 7x minus 23. And the 23 just gets hung out on the outside. That 4 isn't factored out of it. It's literally just being left as a separate term. From here, half of negative 7 squared. Okay, so I'm going to work in fractions here because I strongly recommend you do get comfortable with the idea of not using a calculator. But if fractions aren't your strong point, you can always check by also doing it with a calculator. So 7 over 2, I'm going to leave as 7 over 2. I'm going to square it. And squares apply to both the numerator and the denominator. So I'm going to end up with 49 over 4. 49 over 4 has actually been added 4 times. So 4 multiplied by this actually cancels out my denominator. So what I'm really wanting to do is I'm wanting to subtract 49 from the outside. And so my final answer is going to be 4 times x minus 7/2 squared minus 72. Okay, so we will run into fractions when we're dealing with completing the square. It's a reality. If you feel the need to work with a calculator and work with decimals, go ahead. But I recommend that you do try and get comfortable with fractions.